Our technology automates a complicated behavioral analysis that can save time and serve as a springboard for many different types of studies.
With our technique, the task and the reward are the same thing. There's no disconnect between performing a vague task, possibly incorrectly, and receiving a reward. Animal models provide an opportunity for testing approaches to augment recovery after a neurological injury. For example, in my lab, we test approaches to augment recovery post-stroke since there is an urgent need to develop innovative new approaches to post-stroke rehabilitation.
In addition to stroke, our auto trainer could be useful for studying motor learning before injury, as well as in models of Parkinson's, Alzheimer's, or traumatic brain injury.
When a mouse reaches its goal weight, start a training session by placing a 45 mg pellet on the pellet surface directly in front of the slot and allow the mouse to retrieve the pellet. When the mouse associates an open slot with being fed, use a pair of tweezers to hold a pellet in the same position that the mouse has retrieved the pellets previously. As the mouse begins to bite for the pellet, pull the pellet away approximately half a centimeter such that the pellet is out of reach of the mouth. When the mouse extends a paw through the slot, reinforce the behavior by allowing the mouse to eat the pellet. While not instrumental to experimentation, record whether the left or right paw is preferred. As the mouse associates extending a paw with eating a pellet, further reinforce the behavior by withholding the pellet in response to attempts to retrieve the pellet with the mouth and tongue.
Take care to stop your mice from successfully getting a pellet without using a paw, or they will learn bad habits that are hard to unlearn.
Finalize the introduction of the desired paw-reaching behavior by placing the 45 mg